In this video, we'll look at using tests to identify or anions, and those are non-metal ions. The anions we'll look at, or we will identify, are sulfate and then the halide ions. We've got the sulfate ions in here. This is just a solution containing SO4 2- ions. And we identify sulfate ions by adding barium chloride solution. And the word solution is important. We don't just say barium chloride. It's barium chloride solution. And I just add some barium chloride solution to it. You'll see you get a white precipitate. And the name of this white precipitate is barium sulfate. Okay, so that's the test for sulfate ions, barium chloride solution. And in these test tubes, I've added halides. This one is a chloride, this one is a bromide, and this one is an iodide. And to identify or test for halides, we use silver nitrate solution. So anytime you see silver nitrate solution in a question, there's a good chance that it's been used to test for halides. If I add it to the test tube containing a chloride solution, and hopefully see that we get a white precipitate. Now, if I do the same thing with the bromide solution, hopefully you can see that it's a slightly different color, and it's a cream precipitate. So this is a chloride, and this is a bromide. And the name of this precipitate is silver chloride, because the silver ions from the silver nitrate react with the chloride ions in the solution to form silver chloride. And this one, the name of the precipitate is silver bromide, because the silver ions react with the bromide ions to form silver bromide. Now, this test tube contains iodide ions. And I'm just going to add a few drops of silver nitrate solution. Again, we use that word solution. You should see this is a slightly different color. This time it's yellow. So say we get a yellow precipitate. And the name of this precipitate is silver iodide, because the silver ions from silver nitrate react with the iodide ions in solution to form silver iodide. In this video, I'm going to look at how sulfate ions can be detected in solution. So sulfate ions are SO4 2-. So let's imagine we have a solution, and in this solution we've got sulfate ions. So this solution could be sodium sulfate, or it could be ammonium sulfate. So what we do is we add barium chloride solution, or you can say aqueous barium chloride, but it has to be solution in there or aqueous, not just barium chloride on its own. And it's the barium ions which are important here. So when you add the barium chloride solution, they will react with the sulfate ions, and that forms a white precipitate. So the equation for that, or the ionic equation, would be Ba2+, because it's the barium ions which are the key here. They react with the sulfate ions that are in solution. Now these two ions are soluble, so sometimes or often you would be asked to put in state symbols. So aqueous, aqueous, but when they combine, they form an insoluble white precipitate, and that white precipitate is barium sulfate. So anytime you see barium chloride solution mentioned in a question and it's been added to something, your mind should be thinking, okay, this is a test for a sulfate. Now sometimes you're asked to write out a full balanced symbol equation. So let's imagine the solution here was sodium sulfate. Well, then we'd be reacting barium chloride with sodium sulfate, and the metals just switch places. So you would get barium sulfate plus sodium chloride. Okay, we need to balance that. But for these types of identification reactions, it's usually the ionic equation that's asked for. Okay, so that's the test for a sulfate. Barium chloride solution, and it forms a white precipitate. The next one then is looking at how we identify halides. So here we've got three solutions, and we've got a chloride in the first one. There's a bromide in this middle one, and then an iodide. Now the colours you see in the diagram are the precipitates that formed when silver nitrate has been added. The solutions are usually colourless if they are solutions of group 1 compounds. If they're coloured solutions of chlorides, bromides and iodides, you still get the same results. So if it was say a copper 2 chloride solution, which would be blue in colour to start with, we still get the same result when silver nitrate is added to it. So we're going to add silver nitrate to each of these, and this is silver nitrate solution, or you can say aqueous silver nitrate. Now when you read about silver nitrate being added to something, again, your mind should be thinking thinking of the idea that this silver nitrate is being used to test for halides. So let's look at what happens when we add the silver nitrate solution to a solution containing chloride ions. So that's the first one. So you imagine there are chloride ions in this solution, and the silver nitrate solution contains silver ions, and they're the key ions. So they react with the chloride ions to form a white precipitate. And the equation for the formation of this white precipitate is Ag plus Cl minus goes to give AgCl. And again, if you're asked to include state symbols, you would put Aq after the silver and chloride ions because they're dissolved, and then an S after the silver chloride because it's the white precipitate, it's the solid. Then you've got the solution containing bromide ions. When you add silver ions to it, they react with the bromide ions to form silver bromide. And it's a cream precipitate. Then the final halide is iodide. So silver ions from the silver nitrate solution react with iodide ions in the solution to form silver iodide, which is a yellow precipitate.